So we've already gotten through kind of the basics of atomic theory and walked ourselves through philosophers and scientists of the past. I also said in our introduction to this unit that it's kind of a mixed bag of different things. So we're kind of leave that part behind and go into something else in this lesson, and then our third lesson is going to be quite different from what we're doing here, and so on. So this is the name of our overall unit, Qualitative Analysis. So let's find out what that's all about. So this is taking us back to early science courses, grade 9, grade 10, when we learned about chemistry in the first place. So we learned about physical and chemical properties and kind of how to separate one from the other. So a physical property is pretty much anything you can describe about something without actually doing anything to it. So you could easily say what color it is. The hardness is a little bit different. There's different ways to test how hard something is. Like we all know diamonds are very hard. We can do that by testing its relative hardness against other surfaces to see if it scrapes that surface or if the thing you're testing gets scraped instead. Things like melting point and boiling point makes you feel like, yes, you are changing something about it, but we're not actually reacting it. We're putting it in some water to see what's going to happen to it. Does it smell? Usually this one's kind of hard. Depending on where it's been stored, it might pick up smells of other things. If you put it in a bath of water, does it end up dissolving? Is it soluble? Or does it remain the exact same way? It's insoluble. So those are physical properties. And then chemical properties is basically we're reacting it with something else. Typically what we'll see would be an acid. Like if I put some acid on something, will I end up seeing some bubbles? So obviously this is a course that has been taught in person before. Trying it out is a little bit different virtually. I usually come with a whole bunch of different minerals with me, and we're trying to figure out which one is calcium carbonate based on the idea that these are the properties of calcium carbonate. So you could always look up a picture of calcium carbonate, I guess, on Google, but it would be white and slightly like you could kind of see through it-ish. Not quite opaque, but not transparent. Very hard. Obviously a solid chunk. It should have no odor unless it's stored by something that probably, picks up a scent. Not soluble in water. It's hard to tell by looking at something, especially if you've got a very big piece. But there's a lot of shellfish and things like that that are made out of a calcium carbonate shell. So oyster shells, things like that, obviously aren't dissolving over time. So it's not a soluble mineral. It will be slightly shiny, and it will react with acid. So calcium carbonate's a big component of limestone. So if you think of old graveyards and you think of old limestone tombstones, and you can barely see the etching of the words, that's because acid rain and things like that have obviously weathered out that calcium carbonate over time through a reaction, and that is the only chemical property on this entire slide. So anyways, we went through properties, kind of figuring out if I had a cluster of different minerals, if we were in person, how I would know which one is calcium carbonate. That's pretty much what qualitative analysis is to us. So we have a bunch of descriptors, or maybe we have an actual piece of calcium carbonate in front of us, and we're going to use information to figure out what unknown of my group of minerals is the other calcium carbonate. So getting into some stuff that's kind of like a chemistry lab. We've probably done observations before, but inference is something else to us. So observations are usually made during any type of lab, just so you have data to reflect on instead of having to do the lab all over again to remember what happened. So observations usually in a lab might be based on sight. Maybe you see bubbling and things like that, or you hear a pop. Maybe you did some experiments with gases back in your grade 9 and 10 course. Typically, taste and touch won't really help you out, as well as smell. We kind of went there already. We typically don't have too many things that you want to be smelling or inhaling, right? And you usually do that waft method if we were in person. But observations obviously aren't just in a chemistry lab. They could be anywhere in life. So sight could also be the fact that you're driving at night and you see a single headlight approaching you. So that is an observation. You see a single headlight approaching you. Your inference would be guessing what that observation really means. So maybe your initial inference was, hey, a motorcycle is approaching me. But as you get closer, you notice it's actually a car, but only one of the headlights is working. So sight, if you see a single headlight, that is your observation. Taking it any further, that's an inference because you're just guessing at that point. But we will have both things in a chemistry lab. So observations, like I said, usually in a table and made in real time. So timely manner, we went over these things. Maybe you see some bubbles, color change happens, a solid forms at the bottom of your beaker or test tube. Those are all observations. You can see it happen. You haven't guessed. An inference, on the other hand, happens after our observations. So usually you'll have an analysis or a discussion section in your lab where it says, hey, you have all these observations. What do you think this means? So that's where your inferences come. Then you have to make a guess based on your observations, an educated guess. So that's a very short description. I'm going to put up another presentation as well, just to show you how to access our Dropbox assignment for this lesson, because it's a little bit strange.